This is section 2.5, part 1. We're going to look at direct variation in this part. We were going to write a direct variation equation, and then we're going to graph it. So it's two parts to each problem. So, what is direct variation? Direct variation is essentially the equation, and it takes the form y equals ax, where a is a constant. Alright, that is the accurate formula for it, y equals ax. It's essentially the same thing as y equals mx plus b, but there is no b, right? Where b is always going to be 0, right? So then it's a is represented by the same thing as m, so it's kind of like slope, alright? So that's our constant. It's always going to be a number. So, but when we're dealing with the equation, I'm always going to write y equals ax because that's the standard formula for direct variation. So, here's our first problem. It says, has the ordered pair 6, 3 as a solution. All right, so what that means is if you were to graph the ordered pair and then graph the direct variation, the actual graph, the line, would pass through the point 6, 3. So how do you write the equation for this? Well, 6, 3 is an ordered pair, right? And the ordered pair always takes the value x, y. So we're going to take the actual equation y equals ax, and we're going to plug in the values from the ordered pair into the equation. So we can see y carries a value of 3, and x carries a value of 6, and the unknown is the a. So we're always going to want to find the constant first. Alright, and you do that by substituting in the values from the ordered pair. So now I'm going to solve for a. So I'm going to divide both sides by 6. The 6 here cancels, and a is equal to 3/6 or 1/2. Now you're going to go back to the original equation and you're going to substitute the value of a, which is your constant, in for a. So my final answer is going to be y equals 1/2 x. So you're going to use the ordered pair to find a, and then plug a back into the equation. And we've written a direct variation equation. Next, we want to draw or graph our direct variation equation. So I'm going to create an xy coordinate plane. And I'm going to want to graph this line. Alright, y equals 1/2 x. So we've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then 6 going down as well. And so every tick mark is going by 1. You can kind of think of this equation as y equals mx plus b, where your b is 0, so that means direct variation is always going to pass through the origin. It's always going to have a y-intercept of 0, 0. So from the origin, we're just going to move according to our constant, which is like slope. So I'm going to go up 1 over 2. Up 1 over 2. Up 1 over 2. And you really only need to do it once. I've done it 4 times here to make a point. Alright, but when you're doing it on your homework, you really only need to move according to slope once. And here's our equation, y equals 1/2 x. So, why did I make multiple points? Well, what's this point here? 6, 3. 1, 2, 3, 4, 5, 6, up 1, up 2, up 3, and you notice the equation that we wrote and graphed actually passed through that point, and that will always be the case. So that's a nice way to check to make sure you've done it correctly, to see if your line has passed through your point. So, but if you're not graphing with graph paper, alright, you might have a little margin of error, because if you don't have your tick marks evenly spaced, that might throw off how your line looks as well. So that is how to write and graph a direct variation equation.